I'm Anthony Russo. I'm the IT Manager from Open Universities Australia. Today I'm going to talk about our data centre upgrade experience. But firstly I'll explain who we are. Open Universities Australia provides an opportunity for people to get a university education who wouldn't ordinarily get the chance. We are owned by our 7 shareholder universities, those being Curtin, Griffith, Macquarie, Monash, RMIT, Swinburne and UniSA. We are the largest online tertiary education institution in Australia. Our 25,000 students are usually adults looking for the most convenient way to fit education around their lives. In 2003, Open Universities Australia put in place a range of initiatives to increase our growth. Some of those initiatives being web advertising, a change of name. All of those initiatives in place, we projected a 5% growth. IT's role was to ensure that for the next 10 years, the data centre would meet the growth expectations that the company was projecting. So we made sure that we tripled the figure. So IT planned for 15% growth. We also were planning a move to a new building, that building being 131 Queen Street, which was heritage listed. As part of the move, we had to put in place a plan to make sure the data centre, the new data centre that we had to build, was going to last us 10 years based on the projected growth that the company was envisaging. Open Universities Australia exceeded the growth expectations by a large factor. We were, instead of our 5% growth, we were actually achieving 45 to 50+% growth. This affected the longevity of our data centre by quite a lot because we planned for a maximum growth of 15%. So we implemented virtualisation, which was fairly new at the time, but we found out that even with virtualisation in place, we were only going to get back another 2 years, so we were still not going to make our target. So we had a problem. So we reviewed the growth of the company and we reviewed what we would be needing to make the server room last the next 10 years. We needed more space, we needed more power, we needed more air conditioning, and we needed to ensure that the building can cope with all of these things put together in the new data centre. What we found was, since the building was heritage listed, power was our biggest issue. Being that it was heritage listed, we couldn't move it, we couldn't expand it, and we couldn't rebuild it. We had what we had, and that was it. With regards to the other issues of air conditioning, we had only a defined amount of space in the new data centre, and we found that if we were to continue to use the standard air conditioning system, which is called the CRAC units, we were going to have an issue with space. So we had an issue with power already, and now we were going to have an issue with space as well. So we were racking up the issues big time. And the last issue, of course, was the floor loading. We hadn't calculated on what the actual capacity of the floor was. So we asked IBM to come on board in a partnership and help us overcome the issues that we were facing. IBM suggested a few new technologies that we hadn't used before. The first technology was the APC UPS. Instead of what we were doing, we had single units in racks as our UPS system. They suggested centralising all the UPSs into one central unit, and that being the case, if we were to implement that, we would get N+1 redundancy, which meant that any failure of one unit would not bring down any of our current racks, which seemed good. Not only that, it was also very space efficient. So that seemed like a great solution. And the power requirements were actually less than what we were intending to implement. So that was issue number 1 ticked off. Issue number 2 was a little bit more complicated because with the expansion of the data centre, we would need a lot more cooling. What we had in place was the standard air conditioning systems that you'll find in all data centres. They work okay, but they require a lot of space and they require quite a lot of power, and we had neither. So IBM suggested a technology from APC, which we hadn't heard of before, which is quite different in the way it works. It's a chilled water-based air conditioning system that, instead of cooling down the room, It actually sits between the rows of the racks and it cools the rows down. So this technology actually allows us to cool down a high density data center where no other solution could. But not only did it do that, and it did it well, but it was also N+1 redundant. It required a whole lot less power and it required a whole lot less space. So their suggestion of putting these two technologies in place gave us the best space efficiency with the best power efficiency, which was terrific. The last issue that we had was load bearing. The first thing that we looked at was the load bearing on the roof, because if you have air conditioning or chillers, the second part go onto the roof, and we checked that out, that was fine. What we didn't check out was the floor. Again, after we reviewed this, we had to actually put steel beams to reinforce the floor, so that's something to remember for everybody else doing data centers. What we had in place, once all of this technology was put into the new data center, the space that we used was a lot less than what we planned. The power that we used met the building requirements power, so there was no issue with power. And the air conditioning requirements was not only space efficient and power efficient, but it also cooled down high density computing data centers, which none of the other options that we looked at could do properly. Now, thanks to the partnership with IBM, we have a high density data center that's space efficient, that's power efficient, and due to the technologies implemented, is also green friendly, which puts Open Universities Australia in a fantastic position to meet the challenges for the next 10 years.